So welcome everybody. I'm going to be giving you a talk on using Kubernetes and hostile networks. So who am I? I work at a startup called Dark Cubed. We are developing a cybersecurity platform, part of which is an appliance that runs on customer networks. And I'll dig into that a little bit deeper. But first and foremost, I'm a husband and father of two, CTO at Dark Cubed. Originally a Ruby programmer, switched over to Go a couple of years ago. I like to hack around on things, offensive security type stuff, and used to work at a national laboratory in a previous life a few years ago. So what is Dark Cubed? As I mentioned, it's a cybersecurity platform. It essentially helps organizations look at the bad stuff that's on their network, sits on their network and captures traffic. Like I said, we're a startup, only been in the world a couple of years, and by and far, CoreOS and Kubernetes have done nothing but help us get to where we are today. There's no way that we could reach our goal of being up and running on a customer's network in less than 15 minutes capturing traffic and showing them what's on their network if we weren't able to have access to the technologies that we have. So how does it work? As I mentioned, we have a network security appliance that runs on a customer's network, slurps up data, does some local analysis on it, stores it, and sends only a small portion of that data up to our DOC, our D3 operations center. The DOC runs in Google Compute using Kubernetes as well in a more traditional way that most of you use it. So we analyze, not only do we receive data from our customers, but we're also analyzing open source data, doing analysis, so that we can push data back down to our customers as well. And part of that Kubernetes cluster also manages the appliances that we have running on our customer networks, which is the main focus of this talk here. Why Kubernetes? As I mentioned, in the DOC, it makes sense. That's what everybody uses it for. We have a bunch of microservices that run in GCE, doing a bunch of different things, talking to each other. From an appliance perspective, it allows us to do the release early and release often. So each appliance is a Kubernetes node constantly calling home. We need to roll out a new update once every week or so. We can easily do that. And it's the fast and simple way to do things. Customers don't touch anything. They essentially receive their device, plug it into the network, and it calls home. And after that, we can do everything for them. So they are literally up and running. I mean, they have to touch the device to hook it up, but they don't have to hook up a keyboard, they don't have to hook up a monitor, they don't have to do any of that stuff. And it's all because of Kubernetes and containers, right? So what's the risk? This is where we mention hostile networks. So we run our appliances in a customer network. We have no control over it. Once it goes in, we can't do much with it at all. We can't guarantee that nobody's going to have access to it. We can't guarantee that nobody's going to do single user login and get into the data that's on that machine. But we use it in a traditional Kubernetes sense where we have a kubelet running. It calls into our operations center to check and see if there's any updates for containers, and then runs those if it needs to. So usual use case in that sense. But we have a lack of control in their environment. We can't control physical access. So customers have access, which is okay, it's their device, but as you guys know, the kubelet is either going to use a client-based certificate or it's going to use a token to authenticate to the master that's running in our operations center, and along with that token comes your normal roles. In most cases, a token can do pretty much anything, right? It can create new pods, it can create new deployments, it can turn things off. You could drop an SSH container on someone's appliance and have it do a reverse connection out so that you can then access it. So there's some good and bad things that could happen, right? So let's say that an insider or a bad guy gets into a customer's network and they gain single user mode access to this device. They have the token. If they're familiar with Kubernetes and how it works, they know exactly what they can do with that token. They can grab it, they can run kube control and do whatever they want to do. They could essentially disrupt our entire operations. They could also access other customers' appliances and look at the data. Obviously things that we do not want to do, right? So how do we do this? How do we mitigate this issue? So we took the approach of leveraging namespaces, service tokens, and role-based access control that came out in version 1.3. We essentially create a namespace for each customer, and if they have multiple appliances, we have this notion of nodes running in a namespace that doesn't traditionally fit. In Kubernetes, nodes don't belong to a namespace, right? But we've sort of shoehorned that in. And we use for each namespace, a default token is created. We use that for authentication and in our RBAC rules. So we developed some custom RBAC rules to tightly limit what a node can do, what it can read, what it can write, and to which namespaces it can do that. So how did we come up with the rules? To be honest, I essentially just did a lot of blunt force work. I created a master VM and a node VM, turned on RBAC with no RBAC rules, and started looking at the logs from the master and the kubelet to see which calls were failing, go into the RBAC rules, turn them on, see what fails next, and just went down that route until I knew exactly what permissions a node needed in order to run the basic resource, which is a pod, and have access to secrets and config maps that we need access to. We don't run services on the appliances or on the nodes that run in a customer network because we're not pushing the flannel or calico fabric down to the customer. So we don't need to run services or any of that. So it's, as you'll see in the RBAC rules, it's just a basic set of your core API groups in the rules that we need access to. I will put a disclaimer that I developed these rules using version 1.3 when RBAC first came out. So some of these may be, there may be better ways to do things now. I just haven't gone back to see if I can update any of my rules to tighten them up. So the rules I show you are based on version 1.3. Be great. Actually, show of hands real quick. How many are deeply familiar with RBAC and how the RBAC rules work? All right, so if you guys want to throw stuff at me and hammer me with questions about why I'm using certain rules, I would enjoy that. And I do want to say thank you to the SIGAUTH Slack channel and more specifically Jordan for answering all my stupid questions that I ended up having. Usually it was the typical MO of I asked the question and then as soon as I typed it, I figured out what the answer was, but he made it obvious that I was going down the right route. So in summary, I don't know if you guys know this, some of you probably do, but the master by default does not validate that a token actually exists in etcd. I'm assuming it just makes sure that the signature is correct and then goes on with its authentication scheme. So definitely the first thing we did was add this flag to our API service to make sure that part of the authentication procedure is to make sure that the token still exists in etcd. That way if a token does get compromised, we can delete that namespace or at least regenerate a default token. And the old one will no longer work. If you don't add that flag, the old one will still work. Nodes, we actually turned off the register node. By default, it's on, which means the node needs to have the RBAC permissions to create nodes in the cluster. Probably wouldn't be too big of a deal if an adversary was able to create nodes in your cluster, but for me, if I went in one day and said kube control get nodes and saw a bunch of nodes that I didn't create, I would be a little bit worried. The kubelet can list and watch all nodes, and when it lists all nodes, it gets every single piece of detail about that node. There's actually nothing that I saw that I could do about that. If you don't allow the list and watch, the kubelet never completely starts up. It only lists and watches for nodes in the entire cluster when it first starts up, and never does anything with that afterwards. At least not that I could tell. But I had to add those. I had to add those resources in, otherwise it would not work. Let's see. Nodes can post events. So events are namespaced. Since nodes are not, node events are posted into the default namespace. So obviously I wanted to add a rule to make sure that they could do that. And a node can post its status, but only for itself. So which makes sense, right? You don't want an adversary to be able to post a status for somebody else. That would essentially make the master think that they're not ready and would no longer be sending them updates. For pods and secrets and config maps, again, the node can list and watch all pods across all namespaces. I'll dig into that a little bit deeper as to why that is. I allow the listing and watching of services. I mentioned that we don't use them, but just to keep the logs from getting junked up about not being able to do that, I go ahead and allow that to happen. But there's really no data that comes back with that, at least for these specific nodes. I only allow a get for pods and secrets and config maps, and a client should never have to create them. It should only need to get them. They can only delete in their own namespace. As you know, when nodes are told to delete certain things, they like to post back that was actually done. And they're actually responsible for deleting them, not just for going back and saying that they're ready to be. So we had to allow that. Again, pods status can be updated in the same namespace. And we can create and patch events, but again, only in the same namespace. So you'll see a theme here. Anything that's namespaced gets limited to only that customer. It's unfortunate that node events go into the default namespace because it sort of nasties up all of the cluster role rules, as you'll see later on. Sorry for the small type here, but I wanted to stick these together so that they're easier to see. So just to go into deeper detail, node rules. I have a cluster role named node monitor. The resources nodes you can get, list, and watch. Let's see. We could limit node get statuses to just a particular namespace, but you actually get the same data from a list call that you get from a get call. And so there was no reason to have a separate rule for just getting nodes. And so we tie it to any service account token can do these. We don't tie it to a specific namespace, obviously, because nodes aren't in one. And essentially, any service account should be able to do this. And it's not going to hurt anything if they can. So for events, nodes can create and patch them. And again, that's just tied to any service account. There was no reason to limit that to a specific, because everybody needs to be able to do it. Now this is where we get into the specifics of a customer. So when you want to update a node status, again, that goes in. No, that is not namespace specific. So we ended up having to. We want to limit it to the resource name of the appliance. Luckily, we can do that here. So we don't want somebody to be able to post a node status for another appliance in another namespace. So we limit it to only this one. However, because this is not namespace and it's a cluster role binding, we have to dirty up the cluster role list for every customer that we have. So that list tends to get very long. It's not a namespace list. when you do get cluster roles and cluster role bindings, you start to see a huge list as we add more customers into our environment. But that's just the way that it works. It's not too big of an issue. Pod rules, as I mentioned, we want to be able to list and watch services and pods that are supposed to run on a particular node. We do this as a cluster role binding as well because list and watch has to happen. We can't limit it to a namespace when, like I said before, when the kubelet starts up, it wants everything. Not sure why. It doesn't seem to do anything with it that I can tell, but it will not continue on and continue to start up if it cannot do that. So we don't limit it to any specific namespace here. Even though pods and services can be, there's no reason to. We start to get into the meat of how we can keep stuff namespaced here. So we can get pods and secrets and config maps. We can limit those to namespaces. We can delete pods. So once the kubelet knows what pods and secrets and config maps it needs access to, based on information that it gets from the list and the watch, it needs to go out and get those. So it makes individual calls. We can limit those to the particular namespace. And all the resources are namespaced here, so we can use a specific role binding. We can still use the default service account to allow that token to be used, and we can limit the namespace to the what we call the customer code. So we have a customer code template here and an appliance name template here for the node. So that only allows the default token for the service account in this namespace to do these actions. Now you notice that the API groups is the core API group. If you're not familiar with the limitations on core, so any resource that you make where the API version is just v1, there's no extension /v1 or anything like that, it's just v1, then that's just a core group. So that's things like pods and secrets and config maps and services, I think, is in there as well. A lot of the newer things like deployments and things like that are actually extensions. Luckily, a node should never need to create a deployment or read a deployment or anything like that. It's just going to need to know what pods it needs to be running. So we can limit our API group to just the core group. So let's see. What do I think would help from a Kubernetes perspective? What changes might help? Again, and maybe somebody here can answer. I'm not sure why the list and the watch on the nodes resource needs to happen. I'm not sure why a node needs to know about all of the other nodes and why a node needs to watch for new nodes being added and deleted. But it would be useful to maybe know that. And it would be interesting. I know that nodes aren't namespaced in a traditional sense, but at least from our perspective, it would be handy if we had a namespace flag on the kubelet where we could say only pay attention to pods in this namespace or secrets in this namespace. Again, that's sort of specific to our use case. We're not a traditional use case in that sense, and so it may not be worth it. May be a lot of code change for sort of a one-off use case, but if I could have whatever I wanted, that would probably help us out a lot. So, for example, we wouldn't have to have the RBAC rules for all of the pods that are running on this node. They would just be limited to automatically to the namespace that we want that node running in. Let's see. So, in summary, it's been great to use Kubernetes. We've learned a lot. We've been able to do, I would say, we've been releasing code for a little over a year now, and we've been able to do 50 some odd releases of code. So at least about once a week. And Had we not had Kubernetes, we probably would have spent a lot more time writing an agent to be able to do what we're doing, and Kubernetes pretty much gave us that. So for a while, I will admit that we were running with without the RBAC rules with the default token on the appliances for some of our early adopters. So luckily, we didn't get too far down that road before we were able to switch all this up. But it would have been pretty devastating had somebody gotten on there, logged in single user, got the token, and been able to pretty much do whatever they wanted to. Again, it's a pretty limited, it's a pretty narrow base of knowledge. Somebody would have had to know exactly what we were doing. And as this community grows, it'd be a lot easier to do that. But we were probably protected a little bit with security by obscurity from that time on, but I don't want to rely on that. And obviously, container Linux really helps us out in that we don't have to worry about OS updates. They just happen, right? So our appliances run, they're continually updated. We were good developers and developed for failure so that when they restart on updates, they come right back up like they should be. And they run low overhead, can still capture a lot of traffic. So anybody interested in using Darkcubed, you can get a free trial. Go to the link here. Thanks for listening to the talk. I know we didn't take as much time as we probably needed to, but I'm hoping, I left a lot of time, I'm hoping we have a lot of questions, or for you guys who know RBAC rules like the back of your hand, I'm hoping you guys can give me some feedback on what I could have done differently here. So any questions or comments about our rules, or any questions about how and why we're using Kubernetes like we are? All right, no. Yes?
We're studying on slides.
Yeah? Oh, for the slides? Actually, I don't.
Those rules are.
Yeah, the rules are useful? Okay. Yeah, sure. Let's just say I will put them at CoreOS-slides. We will have those up.
On that side?
So take that link,
Okay.
but add a slash slides on the end of it, and we will post the slides up there so that you guys can grab the rules. And I can also create a GitHub account or I can create a GitHub repository where you can download those well. Let's see, we actually have a GitHub, but it's just Darkcubed. So just go to darkcubed/RBAC on GitHub, and I'll make sure there's a repository with the rules also. Any specific questions about the rules or comments about how we're using Kubernetes in the way that we are? Yeah.
Hi, thanks for the talk. Not so much a question, but a request that I've had the same experience you did with trying to figure out how RBAC works and saying like, okay, well, what rules do you actually need to prevent or whitelist a particular operation, because the docs barely cover it. Right. Sounds like you did a lot of digging in order to figure out exactly what calls are needed for which of the components to run. If you wanted to contribute some of that back to the docs, that would be super helpful to the community.
Okay.
Oh, thank you.
So I did a white paper describing the test environment and then some of the steps that I went through. So I can take that, and if you have suggestions on if there's a repository for, I'm assuming, I know there's a repository for the documentation, so I can go and do it.
Yeah, or maybe just making that publicly available so someone can use it as a source for docs.
I can make it available in the same GitHub repository. Thanks. But yeah, it was an interesting process for the wash, rinse, and repeat on, like I said, I essentially turned RBAC on with no rules, turned on the logging in the kubelet and the master to see where things were failing, added a rule, lots of questions on Slack about what API groups were and what I should add in there and where the documentation is for that. Back when version 1.3 came out, there was literally no documentation. Last couple of days I've been refreshing on what's out now, and there's a lot more documentation now. But, I'll definitely try and get something
One more question about authentication. How do you control the end user or developer to authenticate to Kubernetes cluster?
So we actually don't let the customers authenticate to the cluster. We have an app that runs on the node that runs on their network, and it's just there's a lot of apps that run on it, but one is the web app, and that's what they authenticate into. But the end user never even needs to log into the cluster or anything like that. It's just for us to quickly push down updates to our applications that are running on that node, and then they access those applications. So luckily we don't have to worry about end user authentication into our cluster. That's handled by our applications. So I will say it was less obvious to me that I could even use a service account token for the kubelet to authenticate into the master. And I'm pretty sure it was Jordan that sort of said, duh, come on, it's just use the service account token that exists by default in each namespace. And once that realization hit, it made everything else fairly easy to do. So, and it did take me a while to figure out that on the master you have to tell it to actually check in etcd that the token exists or not, because I kept trying to figure out why when I changed the token I could still gain access to the cluster. So that was a exercise of looking through all the options and finally realizing that one is on there because there was no documentation on that as well. So. Okay, well if there's no more questions, thanks for attending. Sorry I talked so fast, and